Hello there, this is Professor Eckhouse, and I'm going to talk about multiplying and dividing radical expressions, things with radicals, like square roots. All right, so let's start with a little warm-up. You try these things without me saying much. Okay, so give it a try. Pause the video and try as many of them as you can. If you can't get them all or don't know what you're doing, watch me do a couple and then pause it again. All right, so x to the 1/2 means the square root of x. That's what it means. So x to the 1/3 would mean, well, I'm having a hard time writing already, would mean the cube root of x. All right, so x to the 3/4 means the 4th root of x cubed. So the pattern follows the same every single time. So now try to go the other way. So this means x to the 5/3. So write the rule. Try the rule. So the rule is x to the b over a, the way I've got it written there. Okay, so try simplifying all of those. So the square root of x squared is x. The cube root of x cubed is x. The 4th root of x to the 4th is x. So the nth root of x to the n is x. That's the rule. Okay. So treat these like a puzzle. Search for perfect squares. So go on a search, like a hunt and search kind of thing, but you're looking for perfect squares. Okay, so there's two different ways to do these. I'm going to show you these two ways a few times. So we're going to simplify this multiplication here. So we've got the multiplication of square root of 12 times square root of 25. So there's a few different ways to do this, but you can multiply first and then find perfect squares. You may see one of them right there. And so I started with a pretty straightforward one. But when you multiply 12 and 25, you get 300. So 300 and the square root of that. So that means now we can break it apart a different way. And you know what? I'm going to back up because I just want to make sure everybody sees what I just did. This is the square root of 12 times 25, all under one square root, because that's what you can do with that. So that is the square root of 300. So I just multiplied it. And now I have to break it back up again and try to find perfect squares. So I know 100 is a perfect square. So I'm going to say 100 times 3. So again, this is like a puzzle. You just kind of hunt for the perfect square. So square root of 100 times the square root of 3. Square root of 100 is 10. Square root of 3. So the other method is prime factors, or you just factor as much as you need to get to it. I'm going to show you the prime factors way first. All right, so the square root of 12 times 25. So the square root of 12 is the square root of 3 times 4, which is 3 times 2 times 2. And then the square root of 25, of course, is 5 times 5. And because we're using the square root, we're always looking for pairs of things. So when you take the square root of 2 squared and 5 squared, you get a 2 and you get a 5. Right? So those come out. But you're still stuck with this square root of 3 on the inside. So when we work all this out, we go back to these on the outside. 2 times 5 is 10, and then the square root of 3. Okay, and we don't have to write the square root. So we got the same answer both ways. All right, so why don't you try both of those methods with this one? All right, so I've got the square root of 5 times 80. 5 times 80 is 400. And you may see right away that 400 is 20 squared. 20 squared. So that is just 20. If you don't see it, you might see that it is the square root of 4 times 100, which are both perfect squares. So you would get 2 times 10, which is 20. All right, prime factors. You could say, let's see, so we've got the square root of 5 times 80. So that is the square root of 5. And I'll search for another 5 so I can put them side by side. And there's a 5 in 80 because it ends in a 0. And then you're left with 16, which is 4 times 4. And so we have pairs of things, and it's the square root. So this comes out and this comes out, and we get 5 times 4, which is 20. Okay, so either way, lots of ways to do this. Searching for perfect squares. All right, I'm going to scoot this up so you can still see the old one in the video and try this one. Notice there are some numbers on the outside already. All right, so it says to multiply and find the perfect square factor. So multiplying means the 5 and the 4 are already on the outside. So we get 20. And on the inside, we have the 12 times the 30. Okay, so 12 times 30, 12 times 3 is 36. And then the zeros on the end. So I get 20 times 360. All right, so think about perfect squares in 360. And I know that there's a 36 and a 10. 36 is a perfect square. So 20 square root of 36 times 10. So square root of 36 is 6. So I get 20 times 6. And then the square root of 10 is still underneath. So the square root of 36 became 6. So 20 times 6 is 120 square root of 10. And that is your final answer. All right, let's do it with prime factors. So with prime factors, I still have the 20 on the outside because I've got 5 times 4. And then a 12 is 2 times 2 times 3. And 30 is 2 times 3 times 5. So you can rearrange this or you can just go find things. So I've got this pair of 2s and I've got this pair of 3s. Are going to come out. So a 2 comes out and a 3 comes out. I've still got the 20 here. And then I've got my square root of what is left here. I've got a 2 and a 5. 2 times 5. All right, so let's simplify all this. So 20 times 2 times 3 is 20 times 6, which again is 120. And then that is the square root of 10. And we get the same answer. We should. Just a different way of doing it. Okay, so get used to it, get good at it with numbers. Try not to use your calculator because then you'll have to know how to do it with exponents on variables. So don't forget all of these rules here. So take a pause and look at those and make sure you've got them all. And then let's try these with numbers. First, let's simplify just variables with exponents on them. So do as many of those as you can. Just see what you can do with it. All right, so we did this in a past lesson. So there's 2 different ways to do this. There's the method using exponents, and there's a method of breaking it apart. So you can think of x to the 4th because we're doing a squared, so I've got to look for pairs. So that is x times x times x times x. Another way to think of it is that is x squared times x squared. And both of these come out then to become x times x, or x squared. Okay, so this becomes x squared. I'm running out of room. Give myself a little more space here. All right, so let's try it the other way. So this means x to the 4th to the 1/2 power. So x to the 4th to the 1/2 power means x to the 4/2, which is x squared. A lot less steps, and we get to the end. Okay, so you might want to do it that way. I'm going to do it that way because it's faster. So this one, x to the 6 square root of x to the 6. Think about what that's going to be. So that becomes x to the 6th to the 1/2 power. And hopefully you could start to go straight to using the rule where we have x to the a to the b root is x to the a over b. I think I switched my a and b from last time, but as long as you've got the idea, you know how to set it up, you can go straight to saying that this is 6 over 2, which is x cubed. All right, try the next few with those rules right there, remembering that there's an invisible 2 on both of those. All right, so using our exponent rule, we would get x to the 6 over 3, which is x squared. This one we would get x to the 3 over 2. All right, so to simplify it, though, that doesn't really work because we end up with still a fraction in the exponent. So when it works like that, you're going to have to rethink it. So the cube root, so that means the square root of x cubed, I'm going to pull out an x squared and get an x. Now my x squared comes out and I get x square root of x, and that is considered simplified. All right, the next one, again, we're going to get x to the 5 halves, which means I'm going to have to find another way to simplify it. So I get, let's see, this is a square root, so I need to find pairs of x's. So I have x squared times x squared. Now that's x to the 4th. I need one more x to make x to the 5th. Now that is x to the 5th. So now this one and this one are both going to come out. So I'm going to get x times x on the outside, and then square root of x on the inside. This one's left inside. And I get x squared, square root of x. So that is a review from a past lesson. So go back and look at the last lesson if this isn't familiar to you. All right, try one more. And this one is cube root. So again, you're going to get x to the 7 over 3, so that's not simplified to a whole number. So we need to say, all right, how is this, what's going to happen here? So we need sets of 3 x's. So we've got x cubed times x cubed, that's x to the 6th, times x, that's x to the 7th. There's my sets of 3. So there's my set of 3 and my set of 3. Those are both going to come out to be an x. And then I'll still have on the inside a cube root of x. So this becomes x squared cube root of x. All right, so let's try some problems with numbers and variables in them. So we get 49 times 28. So I know 49 is a perfect square, and these are squares, so you got to be careful, pay attention to what you're doing there. All right, so we've got 7 times 7 is 49. I'm going to leave that because I know it's a perfect square. And then 28 is 4 times 7. And those are all underneath together. All right, so I know that 49 is a perfect square, and so is 4. So I know those are going to end up coming out. And I get 7 times 2. And then underneath, I will be left with square root of 7. So now I'm done with the numbers. That's taken care of. So now let's look at the x's. So I've got the square root of x cubed times x to the 4th. So let's break this apart so we can get perfect squares out of it. So this is going to become x times x squared, that's the x cubed. And then x to the 4th is x squared times x squared. So if I square root this, how many x's, perfect x's, come out? Right, that's that one and that one and that one. So I get x times x times x. And then I'm left with this one on the inside, so square root of x. So now let's put all that together. The orange ones are on the outside. 7 times 2 is 14. These are all on the outside, so x cubed. And then on the inside, I have a 7 left and an x left. Because remember, these are all multiplied together. Everything's multiplied. I just spread it out a little bit so we could think. Right? So again, just try to see this as a puzzle. All right, so I just caught a mistake in my notes, so I just want to make a note of that. Okay, so moving on. There's a lot of space there, so let's move this up so we can see the last one while we work this one if you want to, and give this one a try, see what you can do with it. These are square roots. Okay, so 32 is 16 times 4. Nope. Not times 4, times 2. So I was looking for a perfect square, and I see the 16 in there. All right, so let's do the numbers as 16 times 2. Now don't forget you've got this times 3 right here. All right, and then let's do the variables as x to the 4th. Now I'm taking a square root, so let's just go ahead and break this up into x squared times x squared, because it's a square root. So x squared times x squared. Now I've got this x squared over here times x squared. All right, so let's go on back to the numbers, and I get the 16 is going to come out. Square root of 16 is 4, and inside I still have 2 times 3, which is 6. All right, the variables, I have square root of x squared is x, square root of x squared is x, x. And again, you do not have to do it the long way. If you can see this, that you're going to get x cubed, go straight to that. All right, so on the outside, I get 4x times x is x cubed, square root of 6. All right, moving on to the next one. Let's move this up. And this is going to be, oh, probably don't want to look at it because this is 5th root. Let's just move this on up because this is 5th root. All right, so 5th root. I see an 8 and a 4. That makes 32. I know that 2 to the 5th is 32. I know that. So look at things like that before you begin, just so you can make a plan. So I see the 5th root of 32 times x to the 5. Well, this one doesn't look, it ends up not being as bad as it looks. Okay, so I'm just going to give up on that one and start again. All right, so we've got the 5th root of 32. That is 2. The 5th root of x to the 5 is x. 2x. Not so bad. All right. Now we're going to look at dividing radical expressions. So again, look at these rules right here, and we've looked at them before, but when you have an exponent on a fraction or a radical on a fraction, it applies to both the top and the bottom. All right, so the first thing you want to do when you see something like example 8 is you want to see if you can simplify this part first. If there's anything you can do, 32 divided by 25, no, I don't see anything I can do. So I'm going to do this instead. I'm going to say, all right, let's look at this, the square root of 32, because I see that 25 is a perfect square. So over the square root of 25. So you can go back and forth between these two versions, just to kind of solve the puzzle, to see what it is that you need to do. All right, so I know 32 is the square root. Look for a perfect square. 16 times 2. 16 is a perfect square. The square root of 25 is 5. So on the top, I get the square root of 16 is 4. Square root of 2 is still the square root of 2. And over 5. So that is your final answer. All right, this next one is a little bit different because we are actually going to go the other way so that we can simplify and cancel things out. So we're going to take this whole thing and put it together under 1. Notice the other one we did the opposite way. And you just have to look at it, make a plan, see how you could possibly make things easier for yourself. All right, so I get 500 over x squared over 4x squared. All right, and I see that my x squareds cancel, and I end up with the square root, 500 divided by 4 is 125. So I know there's a 25 in 125. So the square root of 25 times 5. All right, the square root of 25 is 5, and then that stays on the inside. So make sure you've got this straight. This one is the 5 on the outside, and this 5 is the 5 that stays on the inside. But that's my final answer, 5 square root of 5. All right, let's continue on. The next one is similar, so I think you should probably give that a try. Oh, I forgot to erase this. This is necessary, but for our purposes, not so much. We just need to know that x is greater than 0, so we know we're not dividing by 0. All right, so we're going to rewrite this as the square root of 20x over 5x, and now it's all under the radical, and I can cancel. And then 20 over 5 is 4. So I get the square root of 4. What is the square root of 4? It is 2. So the answer is 2. All right, next one. I'm just going to keep scooting these on up. All right, this is the 6th root. Oh my goodness. All right, so not so bad though. Just give it a shot, see what happens. So put it all under 1 and see if you can simplify it. So I've got x to the 12th, y to the 17, over x to the 6th, y to the 11th. So now remember, x to the a over x to the b is x to the a minus b. You subtract them. So I'm going to get the 6th root of x to the 12 minus 6 times y to the 17 minus 11. So the 6th root of x to the 6th, y to the 6th. Look at that. That is xy. Okay, let's try this one. So very, very similar, except this one is square root. So definitely try this one. Pause the video, give it a try. All right, so if you put this all under the same one, you would see that you have x to the 23 minus 9 and y to the 8 minus 16. All right, so that gives me x to the 14, y to the negative 8. Sorry, I think I got the right thing, wrong thing written down. Okay, so that's all under the radical. So let's fix that, because that should be x to the 14 over y to the 8, like that. All right, so now let's square root that. And remember, when you square root, you're just dividing this in half, that exponent, as long as it's even. So I get x to the 7th over y to the 4th. And that is the end of that one. And we have one more example left. So give this one a try. See how far you can get with it. All right, so this should all be under 1, and I'm going to combine them. 77 over 11 is 7. X to the 6 over x to the 4 is x to the 6 minus 4. And y to the 7 minus 3. So I get the square root of 7x squared y to the 4th. So the x squared is going to come out and become x. The y to the 4th will come out and become y squared. So I get xy squared on the outside. The square root of 7 is still stuck on the inside. And that was the final one. Thank you very much for watching.